sets big M and big N contain exactly M and N elements, respectively. What is the value of N? Okay. Statement 1 says 7M is equal to 8N. So anytime I see something that's sort of in this format, I'm always happy because this is sort of a divisibility concept. This is why divisibility is so important, being able to break things up into their prime factors, because that is a tool as much as it is a type of question itself. So anytime I see something that's like a coefficient times some variable is equal to some other coefficient times some other variable, I'm thinking to myself, so what does this mean? I'm saying these two things are equivalent to each other, which means if I were to break up each side of this equation into its prime factors, every single factor that appears on this left side must also be accounted for on the right side. So here, if we were saying 7M is equal to 8N, and this 8 here, it's really just a bunch of 2's, right? It's 3 2's. So I have a 7 on my left side. That means I need a 7 on my right side. That 7 cannot possibly come from my 8 because 8 does not contain any 7's. So the 7 must be coming from my N. So we could say, what is this telling us about M and N? Saying N is a multiple of 7. And then M must be a multiple of 8 because we have an 8 on our right side, which means we're also going to need one on our left side. Cannot possibly come from the 7. 7 does not contain any 2's. So all 3 of our 2's must be coming from my M. So it's asking us about N. So all we know is N is a multiple of 7. So there's still many possibilities. So this is insufficient. Statement 2 says the intersection of set M and set N contains exactly 0.4 M elements. So I think this is the only Gmat question I've ever seen to use the word intersection in this context. Intersection in the context of sets of numbers. I believe intersection means is the set that contained all of the shared values of two sets. So if I had one set that was 2, 3, 5, and 7, and then some other set that was 2, 4, 5, and 10, the intersection of these two sets would be just the set containing 2 and 5. So we cannot have a partial amount of elements in any of our sets. So 0.4 is 2/5. So this is saying, so if the intersection contains 2/5 times M elements, what is this really telling us about M? It just means, it's really all it's saying is M has to be a multiple of 5. So first of all, this isn't telling us anything about N really, so that's what they're asking about. So that's going to be insufficient. Now looking at them together, what do we know? So together, M will still be a multiple of 8, N will still be a multiple of 7, but now M also has to be a multiple of 5. So if it's a multiple of 8 and a multiple of 5, M is really a multiple of 40. So if we know M, it's got to contain an 8 and a 5. So now our N also must contain a 5, right, to make up for the 5 over here, because that 5 is not coming from our 8. So N is not just a multiple of 7, it's a multiple of 7 and 5, which means it's a multiple of 35. Now, they're saying we need the exact value of N, and so just knowing that it's a multiple of 35 is not going to be enough, because so we can have one possibility where M has 40 numbers in it, N has 35 numbers in it, and in this case they have 2/5 times 40, 16 numbers in common, But that's not really super relevant. Or we can have a case where M has 80 elements and N has 70 elements. And in this case, they would have 2/5 times 80, so 32 numbers in common. But what makes this still insufficient is the fact that we can come up with different values for N, right? So our answer here is still E.